All right, we are COMP397 in the fall 2018 semester, and it's week 2, part 1 of our broadcast. We're going to talk about an intro to CreateJS. The groups in the class, and this is something I couldn't record, we're working on their contracts up until now, I guess team contracts. And we also talked about how next week you're also going to have do your game pitch. So next week we'll have some presentation time, most likely in the first hour of class. Your game pitches must be available to be presented in the first hour, although the final version is due that night at midnight. Okay, so that's the way the game pitches are going to work for next week. Game pitches take no more than 10 minutes. If there's only 5 groups, 1 hour max with feedback, right? So, and then we'll get into the next topic. This week, what we talked about, again, the team contract, the game pitch is due next week, and the game design document, plus peer review 1. Peer review 1, which is due next week, is going to be something where you talk about your team, and is everybody doing the right things? Or maybe people aren't contributing or not showing up or whatever. So that's worth 1% of this 5%, right, is your peer review, which is going to be due next week. Okay, so I'll have an extra document you fill out that day. Just in terms of how things have been going so far. 2 things. So you did this contract, and you're doing the game pitch. And then assignment 1, which is a simple game, which is a slot machine game, is also, it says due week 4. I'm probably going to give it to you next week, and I may make it week 5. Okay, only because of the timing. All right, because you have an assignment 1 that you have to take care of. And then you'll have assignment 2 that's due around week 6. And what I'm going to probably do is extend that to week 7. Just push that out a little bit, only because of the timing of how things have gone so far. All right. So again, my thinking is that assignment 1 will be due week 5, and assignment 2 will be due around week 7. And we'll talk about that. All right. So things to note about how this all works. So today we want to talk about more about CreateJS and the canvas element. All right. So last week I had shared with you a template. So if you look up on GitHub, let's look at GitHub. If I look at Centennial College, please look there. There is a F2018 lesson 1. There's a 2018 lesson 1. Right, so that's something that we will be looking at. Please download COMP397 F2018 lesson 1 if you don't already have it. So people that are new in this room, I would recommend downloading this now. Also, for the people that are new, please sign up for Slack, because the Slack channel is how I'm going to be communicating. If you look on week 1's content, there is a Slack invite. So please connect with me on Slack. I use Slack a lot more than email. Yes?
Can we continue with our own project? We follow with you?
Yeah, do whatever you want. I don't recommend you not follow me technically, though. This is going to be something you need to all do. And you can always put it on pause and get it done by tonight, the team contract. But it's up to you. It's your time, right? Yeah, I mean, I'm here for you.
No. I'm looking at we need to down the project, or we can continue with the project.
Oh, can you continue with what I showed you last week? Yes. Yeah. So that's what I'm going to do. I'm going to continue with last week's project. And so please, for the people that were not here last week, please download that project. If you're working remotely, you can also, use the project that I've put up on GitHub. It works. If your project, you're working here last week, but you somehow didn't make the project work properly, or it didn't work like my project, this is an opportunity for you to use my project as opposed to yours. This is the project template. One more thing that I will do for you to make it easier is I'm also going to put this project template. So I'm going to maybe zip it up. So I'm going to compress it to this. And I'm going to drop it onto Slack. So that way, if you can't find everything, let's go to 397. or if you have trouble finding the things you need to find on GitHub, I'll drop the template on Slack, and then you can always use this template to follow along, because I really do know how difficult it is sometimes to do this for the first time. It's not easy, but we talked about a lot of things last week. Here we go. We talked about a lot of things last week. And if you weren't here last week, then you're in a bit of disadvantage, because we also discussed TypeScript. So please follow there's some videos from last semester that I put up on setup, but however, I will repeat myself a little bit today. Okay. So if all of you have had a chance to download the app, I use Visual Studio Code. All right. So Visual Studio Code is kind of like Visual Studio just for the web and web services. So if you look at here, like, of course, there's always an update. Here, I'll give you a chance to download and install Visual Studio Code. You get that by going to the website that I posted on Slack. Excuse me, but you can go there again and look up Visual Studio Code. So VS Code, download. You do that. It's right here, and it's, as you can see, it's cross-platform on Windows, Mac, and Linux, which is really good. So it's a good editor all around for those kind of things, and it's they keep it fairly updated, which I like. It's a Microsoft product, so it's Microsoft is known for their tools. Tools, Microsoft, they go together. And actually, lately, Microsoft is known for their Surface tablet, which is really cool, right? It's not bad. It's not a bad little machine, and it's especially the some of the stuff they come out with lately even rivals in price the iPad, right? In terms of performance. So not a bad little environment. Okay, so I'm just gonna get rid of this, and I'm going to load up. So again, I'm going to open folder, and I'm going to look at the desktop under COMP397 F2018. And you can see that what we did last week. I'm just going to go over some of the stuff just to review what we kind of did last week. So this is the project folder as it stands. Okay, so the project folder has a bunch of file folders itself. Okay. Visual Studio Code, for those people from last week, just as a refresher, is whatever we do in Visual Studio Code, it's mirrored in the operating system. So that means if I look at the folder, which is the related folder, which is F2018 lesson 1, notice that the file structure is mostly identical, right? The only thing that's missing is this .git folder here. It won't show you the .git folder, although you could show it if you wanted. There's ways of showing it with references. But notice that it's almost identical here and here, which is good. That means anything I do in the operating system is reflected here, and anything I do here is reflected in the operating system. That's number 1. 2, we use Node.js. So last week we did a setup with Node.js. We used that as a package manager, and we're using Yarn as a package manager. All right. So again, the way it would work is if I pulled up a command prompt, and I can do that with Visual Studio by doing what? What keys are the shortcut for the integrated terminal? Do you remember? Anybody? Control backtick. So if you press Control and backtick, it'll bring up the Visual Studio Code's integrated terminal. All right, this one. So what this does, the integrated terminal, it allows me to directly control what's happening in Visual Studio Code. And so I don't have to swim to it. I don't have to do CD space and then the name of the folder. So that's one thing I used last week. The other thing I did, which was really important last week, is I used a couple of things. One was Light Server, and the other one was I made use of the transpilation task that you can set up in Visual Studio Code. So the way to transpile automatically in Visual Studio Code is Control-Shift-B. Control-Shift-B gives you an option to either transpile with the watch task or the build task, right? And again, in order for you to use these two things, you must have TypeScript installed locally with Node.js. Yes, yes. Let me go back. So tsconfig.json, remember I made this file happen last week with tsconfig.json. And what this is the TypeScript configuration file to tell TypeScript how to transpile from TypeScript to JavaScript, because with your index.html, if you look at index.html, you can see that it only takes JS files, not TS files. All right, so you cannot transpile, or you cannot use a TS file here in your code. All right, so only JS, which means we have to convert, that's transpile, from TypeScript to JavaScript. For those people who were not here last week, we used TypeScript, and the way to get that, if you look at TypeScript, is through the TypeScript-lang.org website. It's one way to do it. You can actually download TypeScript, or you can use npm. And what I mean by that is you can set up Node.js. So if I go to nodejs.org, we're not using Node.js as a backend server. We're using Node.js for only the package manager alone, right? And usually my version should be something like 10.10.0. And I went, again, to check your version, you can go to command prompt and just type node -v, and 10.10.0 should be around there. It's what I have. You should be something like 10. something. If you have another version like 8. something, you can always download the latest version of Node.js here and install it locally. If you have a Mac, you should use sudo, homebrew, which will prevent the need for you to use sudo every time you add something into your code. So instead of doing sudo npm install, you don't have to do that anymore. You can just use the commands like normal. So homebrew is the way to do it. I shared the homebrew link on Slack for you guys. All right, so we can also check the version of Git, because we're going to be using GitHub in this course. So last week I asked you to submit your Git repository, right? That was one of the first things I asked you to do. It was a lab that I asked you to put in, and you should be able to detect the version of Git. If you put Git -- version, it should tell you the version of Git that you're running on your system, because we're going to be using Git for everything, right? Git, of course, is a version control system that we're going to be using. Are we good? So that's where I'm at from last week. Again, you can look at some of the videos. I shared the YouTube videos for you guys, right, on week 1. So if you missed something, you can always go back to my setup videos from a couple of semesters ago, which are almost identical to what I'm going to be doing here. Okay, so there's all the setup videos for TypeScript and Node and everything else they're there from a couple of semesters ago. And so there's no need for me to update those right now. And that's why I didn't record last week. But this week, we need to do a review of what we can do with CreateJS. So, okay, so this is your folder structure. Take a look. You have your assets. Inside your assets, you have images, and I have one button called the Click Me button, which I made very quickly last week. Inside your content, you have one file, game.css, which just basically outlines your canvas in black, right? And inside node modules are all the modules we downloaded from the web. That is our libraries, all the libraries from Meso.js, Sound.js, Tween.js, and Preload.js from the CreateJS suite of libraries. Again, that's the library set that I've chosen again this year. I think it's a pretty good one because we're going to build our own game engine. So if I go to CreateJS.com, these are the libraries that we're going to be using. There's 4 of them, right? They're just libraries. It's not a game engine, but it gives us control of the canvas HTML element so we can populate our game within that element, right? So everything is going to happen inside that element, okay? There's some great documentation. All the API documentation's here up online. So under Easel.js, if you notice, there is a docs section, and under docs, there are every kind of API is listed here for the most part. There are some additional things you can find using Stack Overflow. And if you Google some stuff, there's some examples online as well, but this is pretty good. So that is the technology we're using. So let's start. I'm going to press Control-Shift-B. I'm going to launch my watch task, which is going to automatically transpile, if everything works well, everything that I have from TypeScript to JavaScript. There's only one TypeScript file that I have right now. It's inside my scripts, inside my core folder, inside a file called game.ts. Okay, so I'm going to show you what that looks like. In game.ts, we have a bunch of really bad code right now, which we're going to fix. All right. One of them is I have included something called an IFI, which is an immediately invoked function expression. It's a closure. And the closure, what it does is it stops variables from leaking out onto the console or to other places by enclosing them in this structure. Okay. And you have some game variables that we created last week. We created the canvas variable and the stage variable and hello label and click me button. Those are all things we made last week. I explained that the canvas is an HTML element that you have to make a reference to that physically sits inside your index.html file. So if I look at my index.html file, the only thing we have in this file is the canvas element. There are no other elements. You don't have an H1 tag. You don't have anything. Just this and some links to your style sheet and your JavaScript files. That's all this is. We've been using a canvas with an ID of canvas and a width of 640 and a height of 480 pixels. All right, and this is where we're going to be drawing everything inside the canvas element. Okay. If I go back to the game.ts file, so that's part of it, right? So the canvas, the stage is a container, a logical container that we create through the CreateJS suite of libraries, right? And the stage object is going to be where all of our game is contained within. Okay, so that's the stage object. And I made a relationship with this, so I kind of drew a simple drawing. I'll draw it again this semester and this year and today, so that way we can kind of relate to it. I'm just going to make a new drawing here, just to get it gives you guys to understand. I make it 640 by 480, and I can imagine if you have here is the HTML canvas element. Okay, you have an HTML canvas element. Let's not make it red. Let's make it no color for now. Okay, that's fine too. And we'll give it a border of 1. So that's your HTML canvas element. So let's do that. So let's just annotate this. So HTML, I'll fix it. Canvas element. And of course you can't see it because it's white. Yay! Isn't that exciting? All right, so this is your HTML canvas element, and the HTML canvas element is just a container. Think about it as a dry erase board where you paint pixels, you erase it, and repaint them every frame. The game has a game loop, and the game loop triggers every frame. Each frame is 1/60th of a second, which works out to be 16.66 milliseconds. Non-repeating, non-terminating. Right? So that means like every 16.66 milliseconds, this a frame that triggers. It just does another frame. And what happens is every 16 milliseconds, it redraws the screen. So erases it and redraws it, right? And this gives us the ability to do things like move things on the screen, create what appears to be animations, which are really frame-based animations that move around the screen. So that's the HTML canvas element. And then you have another layer. Okay, you have another layer that is on top of the HTML canvas element. It's a logical layer. Okay, this is the logical layer. Let's make this one, I don't know, green or something like that. There's the green layer. This green layer, which is not really green, I'm just using that color, this is actually the CreateJS stage object. That's what it is, right? So this is CreateJS stage object. And the CreateJS stage object, I'm just going to change the background so it's white. It is contained within the canvas element, if you will, or we use the canvas element as a reference, right? And when we create the new CreateJS stage object, the CreateJS stage object is also called a display list. So this is a display list. Display list. And it's a display list of all the objects we add to the stage. And the keyword to add stage objects to the stage is add child. All right, we're going to use the add child method, right? By the way, CreateJS was created by Grant Skinner. and he has some really great information about it. He's the same guy who worked with Adobe on Flash, right? So the add child method is what we want to use, right, to add things to the stage. So Grant Skinner has been working on CreateJS, and he and his team created this group of libraries to make it very Flash-like. Okay, that's where CreateJS came from, right? So if you're used to Flash and using ActionScript with Flash to create animations, if you're familiar with that, you will be very delighted to use CreateJS because it's very similar in terms of scripting. Most people now don't use Flash because it was kind of ostracized by Apple. They said, Flash bad, right? Code good. And we don't use Flash anymore for anything, for the most part, anything new. But there's still quite a few Flash websites out there, right? And they're going to remain probably for a long, long time. So that's how it works. So the CreateJS stage object sits inside. It's a container that's us display list, and it also allows us to use the add child method to attach things to it. So imagine if I had some kind of object, I could attach it. Let's make these objects a different color. Let's add some objects, right? So imagine if I attached objects to the stage, right? And I could have many of them. And these objects live inside the stage. Here we are, whatever these objects are called, right? And these objects are part of the display list, all right, that belong on the stage. In order for us to see the object, it has to be added. Even if I instantiate an object, and if I don't add it to the stage, it's not shown. It's not rendered until it's part of the stage, the display list, okay? Are we good so far? Theory. So if I go back to my code, right? Here's my code. You can see that I have a stage. And in my start function, I have two main functions here, actually three. I got the start function. By the way, it's very Unity-like the way I've set the project up. I have my update function, and I have my main function. Those are the three main functions in my code, okay? In my start function, I initialize the canvas element, right, by creating a reference to the element on the page, on the index.html page. That's what I do here. This line 12, I instantiate a new CreateJS stage object, and I pass a reference to the canvas into it, into the constructor function. This line 13, what it does is it enables mouse over events. So if I want to click on buttons on the stage, as an example, I have to use this stage.enable mouse over, and I have to pass how often I want to check in terms of frames. So I'm checking, 20 frames per minute, or per second, 20 frames per second. So it's pretty slow, much slower than the 60 frames per second that I use from a movement perspective. If you make this too big, it's going to really kill your performance. Even 20 is high, okay? Then I specify a frame rate for the game, and my frame rate is going to be 60 frames per second. I can try higher frame rates, but I guarantee you that most machines will not support higher than 60 frames per second when we have a full-blown game, especially through the browser, right? There are new technologies out there that are coming. One of them is called WebAssembly, right, which I'm very excited about. And what it does is allows you to write C++ code, right, and convert it to something that is consumable by the web, right? It actually creates an assembly-like, so assembly, code-like structure that some browsers, most modern browsers, are starting to support, right? Which means we may have a much more performant future for the web, especially things like WebVR. It's coming, guys. WebAR, right? A lot of stuff that has no requirement other than a web browser and some piece of hardware, whether it's goggles or a head-mounted display or something else. And it's going to be enabled with WebAssembly, most likely, because it's much more performant than this script that we see right here. Okay, but for now, we're using this. We can also, other technologies that are out there are WebGL. WebGL is another way to do it. And actually, the CreateJS suite of products supports a stage GL component as opposed to a regular stage component. So you can actually use WebGL in your code. However, it provides other challenges, which I don't want to get into right now. That's why we're not using that. All right, once we declare the frame rate, we go on to create an event handler for the ticker. The ticker, every time there's a new tick, it calls the update function. This is, think about the on as add event listener. That's what it's like. So when I say CreateJS.ticker.on, it's like saying CreateJS.ticker.add event listener tick. For every tick event, which is like almost like the new frame that comes your way. When there's a new frame, call the update function. That's what it means.
The name of the event.
Correct. It's the event that the internal event that the people who created CreateJS made. It doesn't really exist. It's just for CreateJS, the tick event. They could have called it the frame event. Same thing. Okay. And then what happens is every frame, it calls the update function, which is right here. So this update function is triggered every frame, every 16 milliseconds. And this is where we call the stage update function. The stage update function is this thing that erases the canvas and redraws everything again. That's what it does. Okay? Then we call the main function. The main function was where all our work happens. And I've created a couple of things here, a hello label and a click me button. All right, so two things. But the click me button, don't think about what these things are. Just because I call the hello label and click me button, they're not labels and there's no buttons yet. All right, we're going to make that today. We have a text object. That's what CreateJS supports, and a bitmap. We have a bitmap and we make it clickable. We're making a clickable bitmap. That's our button. Okay, so again, very low level. We're going to make our own game engine slowly over this course. And you're going to be using the game engine we create together for your game. Please use my code, okay? Please don't try and create your own. Don't download any other code. You're not allowed to use Phaser or somebody else's code, in your engine. So if you're like, hey, I found this really good piece of code and I want to make a snake game. No. I follow this tutorial and it's a snake game or some other kind of game and I want to make the use of the tutorial. No. Please don't do that. Please use my tutorials and be in class and try and make the stuff here. If you can't be in class and if you can't participate, and if you come up here and show me your game next week, I'm going to know, right, that you don't know what we're doing, and it's going to be a trouble, some problems for you, right? So hello label and click me button are just a text object and a bitmap, and we're going to change this today, okay? We also have some additional events that I created. One for the click event for the button, the other one for the mouse over event, and the mouse out event for the button that we created. And that's it. That's all we did. Oh, the way we launch our application, right, which is a good workflow, I'm just going to use another task, another PowerShell, is to use something called light server. So I use light-server, which I showed you guys last week. And what this thing does is it launches a browser window that is synchronized, browser sync, with our application, okay? And the way to download light server again is you use npm, so node and npm. And again, I kind of detail this in another video from a previous lecture, but I showed you guys last week, is what you do is you go npm install. Again, you have to have node working for this to happen. And then light-server -G for global. And if you did this, then what ends up happening is it installs light server in your system, and then you should be able to use it on a command line, like I just did. Once light server is working, we have hello world, which is a very basic program. We're not going to do another hello world today, but what we're going to do is make two new classes and split our files across different classes across different files. Now we're going to go beyond what you learned before, okay? Slightly, maybe actually at the end of what you learned before, right? So if you took a JavaScript course with me before, then this should be review still, actually. If you didn't take a JavaScript course with me before, this is probably all new. Let's get to it. All right, so I want to make use of these buttons, this button and label, but I'm going to have more than one button and label. And it would be great if we had a button and a label class, right, that I could reuse as components in my game engine, right? So what I want to do is I want to create a new script folder called objects. Make a new folder called objects. The objects folder right now is empty. Okay, here's where the new script comes into play. I want to right click on objects and I want to make a new file, and I'm going to call the first file label with a lowercase l .ts for TypeScript. Because I have a watch task, it automatically creates a blank JS file for me. There's nothing to transpile, but it created it because I'm watching the files for any changes. That's what the watch task does. here I am, and I need to create something that I can use in other places. I'd like to surround my files with a module pattern, all right, or a namespace for those people who are familiar with namespaces. And here is the way you do it. You say module or namespace, the name of the module, objects, and you put curly braces. This creates your closure for you, all right? And then we have to use the keyword export because anything inside the module is locked inside of it, all right? And we're going to create a new class that we're going to call label with a capital L, which is going to extend the CreateJS text class, okay? Because we have a text class. There it is, right? And we're going to use curly braces. So what this does is it says, hey, take the CreateJS text class that exists and create a subclass of it called label, right? So this is just an example of how to make a class in TypeScript. And it's a separate file, by the way, too. All right, next. Once we have that, we need a couple things. We need a constructor. I'm just going to, this is my outline, okay? I'm also going to need some private instance variables or class variables, okay? I'm going to need some public properties, okay? So maybe I'm going to have public properties, maybe not. I'm probably going to have some private methods, and maybe some public methods, okay? So I got this, I'm just outlining what my class is going to look like here, okay? My class right now is empty. Let's make my constructor. My constructor has to have the keyword constructor in it. And as per ECMAScript 2016, it's pretty much the same. It's giving me an error. TypeScript is saying, hey, there's a problem because I'm extending the basic text class. I need to call the super constructor. Super constructor, right, is the text class. And it requires actually a bunch of different things. A string, a font, and a color. Okay, that's what it needs. So my constructor is going to feed into it. And what I'm going to do is I'm going to ask for the label string, which is going to be of type string, right? I'm also going to give it the font size, which I don't have, font size, which I'm going to make also a string. Hear me out. And I'm also going to do a font family, which is also a string, as well as the font color, which is also a string. All right, so those are the requirements that I'm going to take in at the beginning. Okay, so long stuff, constructor. So label string, font size. Let's make this on different lines so you can all see it. Not because I want to make this messy, just so you can see it when I'm taking it into the constructor. Okay, so not much difference here. Like there's almost no call for me to use a class like this. However, let's add some other things. Let's add some values. I'm going to also take in the x value, which is a number, the y value, which is a number, and I'm also going to take in, is it centered? Is my label centered or not? If it's centered, I want to change the reference point of the label, the anchor, to the middle of the label. If it's not centered, I'll leave it at the top left corner. And what do I mean by that? So I'll say is centered, which is a Boolean. Okay. That makes sense? So that's what it looks like right now. And that's my constructor function. Now, guys, and there's no girls in the class. So guys, the thing with it is I would probably write this on one line typically, okay? But because, you guys are watching this, I want to share this with you so you see all the details. That's why I'm writing it this way, but typically not. Here's something. I should also think about making my x coordinate optional. And the way to do that is to do optionals is you put in equals to 0. There's the optional. So if you don't give me a value, I'm going to assign a 0 to it. Sorry? Default values. Same thing here. And then also is centered by default is going to be false. I'm going to say it's not centered by default. And if you don't specify, it's going to set it to 0, 0, and it's going to not center it. All right, that's what the default values are. Okay, so these are the things that I can do. So that's the requirement. And then I'm going to pass this information into my super constructor. So I'm passing in my label string, I'm also passing in the font. Notice there's no font size and font family. I'm going to combine the font size and font family here. So I'm going to say something like font size plus some kind of space plus font family and then font color. That's the color that I need. That's all it needs. It's all that the super constructor will take anyway. Okay? So that's the super constructor. Then what I'm going to do is I'm going to check if the user wants the object centered. If they want this text to be in the center of the screen, for example, game over, welcome, you suck, whatever is going to be in the middle of the screen or whatever, then I want it centered. I want to check to see if that's true. So I'm going to say if is centered, if it's true, then I want to take the registration value similar to what we did last time. Take a look at the registration value here. What I did was I said, hey, take the regx and regY values and then measure the object. And if the object, whatever the half the width and half the height of the object is, use those. Wait, half the width and half the height. I probably want to know those things. So what I can do is I may want some public properties, right? And private properties, right, that I want to assign. So here's how private properties work. I can use the private keyword. I'm going to private instance variables. I typically use by convention the underscore. Underscore for me means when you look at that variable, it means private. And then after you get the underscore, the name of the variable. So in other words, width. Okay. And of type number. I can also do the same thing with height. So width, height. I also like to do half width, which is a number, and my private half height, which is also a number. Oh. All right, so that's kind of private instance variables. Those are the data variables we hold, and I'm just using the standard stuff. By the way, I'm really extending this class this time around because there's more gamers and object-oriented programmers here in the class than I had last semester. Otherwise, I would do this differently, all right? So why am I making data variables this way? So I can do information hiding. What I can also do is I can make public properties. And the way you do public properties in TypeScript is the following. I can say that get the name of my variable, so width, right? And what it does when you get the width is it returns, first of all, it returns a number. And I can say that you want to return this dot underscore width. So that is exactly how you do a getter. These are public properties. And I can say that I can also set width with some new value, which is a number. And what you can do is you can say that this dot underscore width is equal to new value. Okay, so that's your getter and setter. That's how you do get accessors and how you use set mutators. Okay, for those people who like to use the OOP lingo. All right. Are you with me? Are you good? Do you understand what I'm doing? I'm creating public faces of your private instance variables, private interfaces, in fact. Okay, let's do the rest. Let's do height as well. So it's a little bit long. And then I'll put this up on GitHub. Get height, which is a number. And I'm also going to return this dot underscore height. You can see where I'm going with this. And I can also do set height, which is some new value, which is a number. And this dot underscore height, right, is equal to new value. All right, so again, it takes a little bit of time to write all this stuff out, but it's from a OOP perspective, it's proper form. Get half height, which returns a number. And I can say that return this dot underscore half height, and set half height with a new value. And I can say that this dot underscore half height is equal to new value. And so again, I'm just getting and setting. I'm getting and setting what?
Why do you do that for half height? Shouldn't setting half height be happening in the access for height?
I'm going to set it somewhere else. I'm not going to calculate it here. And it can't be automatically calculated either, right? Unless, if I want to do that, if I set height, then I can automatically set half height. But wait for me. You're a little bit ahead of what I want to do. You're right. And I also want to do half width the same way. So if I say get half width, which is a number, and then I can say that return this dot underscore half width, and I'll do the last one, set half width with a new value, and this dot underscore half width is equal to new value. All right. I had to write these ones because these are the basics. These are the basic public properties I have to write. Now hold on with me, but bear with me while I continue. So now when we come to if is centered, all right, I can set width and height before this point, right? So again, put a semicolon there. And I want to say something like this. I know what the width and height are going to be, right? So I'm going to say something like width, and I'll say this dot width with a capital W. I'm using the setter here, okay? Hear me out. It's going to be a measured width. I'm going to say that this dot width is equal to this dot get measured width, right? That's the width. And this dot height, right, is equal to this dot get measured height. These are just built-in functions that I'm going to be using. It's like get bounds height and get bounds width, but I'm using something that belongs to the text function. Okay, that's what it is. Guess what? If I measure these two things, I could set the half width and half height here. I could say that this dot half height is equal to this dot height divided by 2 or times 0.5. But why? If I have these functions, as soon as I set up this dot width and this dot height, when I set these two values, I should automatically be able to create this half height and this half width. So what I want to do here is in the set width function, not only am I going to set the width, but I'm also going to set the half width. That's the power of setters, right? Because you can do more than one thing in a setter, not just set the value for a function or a value or a property. So I can say that this dot, and I'm going to use the half width public property. I'm going to say this dot half width is equal to this dot width times 0.5. I'm just going to do that right here in the setter of the width property. So automatically set the half width, right? I'm going to do the same thing with height. I'm going to say that this dot half height, right, is equal to this dot underscore height times 0.5. I'm using 0.5 and not dividing by 2 because it's less computationally expensive to do that. All right, so that sets things up, right? And once I set that up, once I set up width and height, then what I also get to do is check if it's centered. If my user wants my label centered, then I can say that this dot regex, right, is equal to this dot half width, right? Because I calculated half the width. I'm moving my anchor to half the width of the object, right? And this dot reg_y then is equal to this dot half height. Half height. sense? Right? So what I mean by registration values is if I look at my my diagram.
So what time is your class running till?
7:30. You're being recorded. So so when you, sorry, I couldn't help that. So when you have an item, let's say for example I make a I'm going to show you what happens here. Let's say I make a label that's 150 by 50. Here's what the label might look like, right? And by default, if I type something like, start, this is my start label. Make that maybe black. Here. So this is my start label. Let's say I have a start label somehow, and it goes like this, right? So my registration point for all game objects, all display objects, is really by default in CreateJS at the top left corner of the screen. So a top left corner of the object right here. That's the registration mark. And what I'm telling regex and reg-y to do is actually going to move the registration mark or the anchor to the middle. And so that allows me to rotate the object from the middle or start drawing it from the middle so I can get centered objects, right? If not, if I leave it here on the top left corner of the screen, what's going to happen is I can only rotate it from the top left corner or start drawing it from here. This is where I start measuring from. So if I set the X and Y coordinates and if the anchor's here, the X and Y coordinates in the global space is going to start from here. Okay? But if I want it to be centered, I want the X and Y coordinates to start from here. So it starts in the middle. Okay? So that's what this does. And then I want to set that this dot X is equal to X and this dot Y is equal to Y. Right, because X and Y comes from our constructor. We set the X and Y. And if no one sets the X and Y, if they don't put anything, they'll just be 0 by default. So that's what this does. Okay? So that's really my label, my new label object in a nutshell. It's not, I made it more complex than it has to be, okay, just to show you how to make a proper object-oriented class, okay? And if I save it, and if I look at the conversion code for JavaScript, it looks like this, right? Yeah, not good, right? It looks really much more complex. Here's the get and set, right, for the getters. And you can see that they still have, JavaScript has getters and setters, right? We just use the object.define property method to define getters and setters and make them enumerable and configurable. All right, so much more complex code, and this is what it would look like for this class. Massive amounts of code and much more complex syntax compared to this. Much easier to read, okay? What else do we need? Do we need any methods or anything like that? And for now, I think not. I think I'm not going to put any extra methods in here. It literally only does basic things, okay? So now we want to attach this new class to our files, okay? Because right now we made the class, but it has no association with my files whatsoever. In order for me to use this class, it needs to be attached somehow to the index.html file. So going back to my index.html file, now that I've made the class, I need to attach it. You got to go?
Yeah.
Okay, it's recorded anyway.
Okay,
so
I'll watch the rest.
Take care. Thank you. So these are my these are my game scripts. That's what I'm going to call them. So I'm just going to organize this in the index.html file. And if you look here, what I need to do is I need to do a new script, right, where I connect my scripts and then objects and then label.js to this. Also, just as a note, I'm probably better off putting a slash in front of here, which means go to the root of my folder, then look at my objects. Go to the root of my folder, then look at node modules. Because if I don't do this and I deploy this to a web application in the future, which I'm going to do with you guys, right, then sometimes this won't go to the right place, right? So that's what this does. Same thing with my content. All right, cool. So that's what this does. I added the label class in here, right? But I haven't used it. I just made a new label class, and it's in a separate file. right? That's what I've done. So let's use it. So I'm going to go to here, and then I'm going to go into my core files, right? And I have this label right here. I'm going to replace it with my new label class. But first, at the top, where hello label is of type createjs.text, I want to see if I can create my own class. Now, this is something that I want to show you. So if I go, I know my label exists in the objects namespace. So I got to say objects.label. But guess what it does for me? It does absolutely nothing right now. It doesn't give me any code hinting whatsoever when I hover over label. In fact, all it says is it's of class objects.label. I'm going to have an error now because down here, right, you can see that hello label is of type label, not of type text. So I need to do this change here. I have to say that it's of type new objects.label. Let's do that. So if I kind of replace this stuff and I said objects.label, I can do that, but it's a problem. And it tells me that there's a problem because objects.label require the following things. I need a string. I need, 4 strings, maybe, and 2 optional numbers, and an optional Boolean. But this does not give me that in this format, right? I got to change it because that's what I asked for. Hey, by the way, I don't need this stuff. And I don't need this stuff. I'm going to replace this in a second. So I only need this one line. That's why I made this thing in the first place, all right? So hello world is my label string, right? It says expected 4 to 7 arguments, but only got 3, right? Wouldn't it be nice, though? I'm gonna get rid of this for a second. 60 pixels, right? Wouldn't it be nice, though, if my objects.label gave me some additional code hinting? You can do that by using something, an add-on to Visual Studio Code called Document This, and which I highly recommend. You can get these add-ons by going down to extensions. Here's the extensions, right? So the reason why it's giving me these ellipses is because I'm in expanded mode. You don't have a lot of room. So I'm going to go down to extensions. And under extensions, there's a new extension that I recommend called Document This, right? Document This, which automatically creates documentation comments for you in your code, right? I recommend downloading it. Document This. Okay, so how do you use it? I got to go to my label.ts, and here in my constructor, which is where my stuff is happening, I'm going to use the / and then double asterisks, right? Notice that it brings up an option for document this. And if I press enter, it does this for me. It actually creates documentation, right? And this is good for API documentation. It starts off my API documentation, all right, for me. I don't need member of label. That's probably not necessary. But the rest is really cool because what it does is it creates the requirements in terms of what I'm looking for specifically. And it tells TypeScript, it helps TypeScript give me parameters for me to create my stuff. Okay, so document this. By the way, you can use document this for every method, which is actually pretty awesome. All right, so how does this look in my game.ts now? Well, if I go down to label again, if I say objects.label, and if I open a bracket, guess what I get? I get a better description. It says I need this stuff now, right? So I'm actually documenting my own class, which is way better than not having any code hinting. This actually gives you all the code hinting you want, and I can put in as much detail in the description as I want. Okay, so I need a label string, which is going to be hello world. That's my label string, and I also need a font size, which I'm going to make for now. Let's call it 60 pixels. And I need a font family, which I'm going to say is Consolas. And I need a font color, which I'm going to say is black, 0000000. Do I need an X and Y coordinate? No, I don't. But I'm going to put it in anyway. It's going to be 320, right? And my Y coordinate is going to be 240, right in the middle of the screen. Is it centered? Yes. I'm going to send in true. And that, my friends, is how I set up my label. So I'm using my label for the first time. So let's test it out and see if it works. I'm going to save this thing. And if I did everything correctly, then we should still see the same hello world label. But it's using my new label class, not the text class that came with CreateJS. So let's take a look. I'm going to go to my files. And yeah, there it is, hello world. It's centered, right? The way to check this, first of all, I want to check in the inspector. I want to check in the console. Do I have any errors? No, number one. The other thing is I also want to check sources. And in my sources, if I look at scripts, I can see inside of my objects that there is a label.ts file. Now that I saw that, I know that it must be loading this. As well as in my index.html, right? I can see if I scroll down on the right that I am loading my label.js file, right? So this label, hello world, is actually coming from my class. It's an instance of my class label. That's what it is. Questions around classes. I created a module. I separated my class in a different file, and I attached it to my index.html because my index.html is a manifest, right? And then it's automatically transpiled. Let's put this up on GitHub. So, yeah.
How do you run this code?
How do I run this?
Yeah.
Remember what I said? You need light server.
Oh, yeah.
Light server. If you run light server, it automatically runs the browser synced version of this code, so it updates. All right. Well, let's update this. So I have 7 changes to my code, and I'm going to say that I added the label class, right, to the objects library. That's what I first did. That's the first part of my game engine. Oops. Let's also stage everything. I'm using the built-in Visual Studio Code GitHub controls. You can also do this by hand with your terminal. But notice I'm clicking on this little GitHub button that's part of Visual Studio Code. Then I'm going to click this little check mark. On the check mark, the 2 things I just did was git add dot, right? And git commit -m. And I put in added new class, blah, blah, blah. That's all I did just now. I just did it with the tool. And now I'm going to push it to GitHub. I'm going to go to these ellipses. I'm going to say push. And that's going to push my new code to GitHub. So if you didn't follow along, or if I was too fast, please look at the files on GitHub. And again, where are those things? I showed it to you earlier. It's right here. So if I go refresh, you can see now that lesson 1, which I'm updating right now, is on GitHub. It's right here. All I'm doing is updating it. If you look at scripts, you can see that there's 2 folders, one called core, one called objects. And here's my new label class that I just made. Okay? So please look there. If somehow you couldn't follow along fast enough, or if I went too quick, or if you didn't understand something, you can watch the video and actually look at the files that I've put up on GitHub so you can follow those things. Questions so far for my new, how to do a class with TypeScript. Okay, we're going to do one more class today, and that's it. I just wanted to talk about classes, modules, TypeScript, all those things again, because we're going to be using this template going forward, all right? So please follow along with the code. If you couldn't follow along, watch the video. You need to know about this because you're going to be tested on it on your test, and you're also going to have to do your own assignment number 1. Probably going to I'm going to be giving that out to you next week. All right, let's make a new class. So I have in my game.ts, I definitely took care of my label class right here. But look at this button. If I had to do this for every single button, that's crazy, right? I want to do the same thing with my button class. But there's some things that are very similar to my label class. Very, very similar. I could inherit from my label class, right, to make a new button. However, label and button are kind of not related, not from a business rules perspective, right? Like you got to think about this, right? The 2 classes are somewhat similar because they're display objects, but beyond that, they don't have a relation. The label and buttons are 2 different things. However, you could say that a button has a label in it. I'm extending the button, a label for the button, and a button also has a bitmap to it, right? It does. So, I mean, depending on your philosophy, you could say that I have a bitmap component for the button, some kind of thing that I want to draw, or you can make it a shape. It's up to you how you want to draw this out in a thing and not use a bitmap at all, right? Or you can say that okay, so I have a label component that's inside of a bitmap. You could do that too. You can kind of display those things in different order. It's up to you. For me, I'm going to keep it as a bitmap, the whole button, right? But you can make it different ways. And there's been arguments for both, okay? So how does this work? Well, we need to create a new object again. So I'm going to go in my objects folder, make a new object, a new file called button and PS, right? Again, I'm going to use the module pattern, all right? Pedro, you good with this? The module pattern. I'm going to say module and objects again. So it's the same module. I'm not choosing a different module. I'm making this. I'm actually adding to the same module, the module objects, right? And inside the module objects, I'm making a new class that I'm exporting, right? Called button, which does not exist in CreateJS, right? Which extends my CreateJS .bitmap. So we're making bitmap buttons. That's what we're doing, right? There could be other kind of buttons. Okay, I know I'm probably going to have some private instance variables. I know I'm going to have some public properties. I know I need a constructor for sure. I know I need maybe some private methods, maybe. I might have some public methods. And if you notice, this is the exact same thing I did last time, right? I kind of outlined my button class the same way I would outline any class, all right? However, there are some things we can steal from label. What can I steal from label? If I go back to label, I have all this stuff, and it's going to be the exact same. This stuff, right? If I have this stuff, am I ready to make a game object yet? Maybe not. Maybe so. And I've done it in the past where instead of making a game object, right, later on, I made it now. So this is something different. I could make a game object because this game object needs width and height and half width and half height. It also needs to know about regex and reg-y. It needs all these things that I normally ask for in a game object. That means I need to make an abstract class called a game object that label inherits from. So instead of inheriting from CreateJS.text, it actually inherits from this game object class, right? And then I have a text component, right? And if I was going to draw this out, by the way, this is a discussion. I don't have a lot of time. I would love to spend more time talking about object-oriented programming techniques and patterns. But there is a piece of software you can download for free called Star UML. Anyone hear about this? Star UML? We can make a UML diagram, right? This is something new that I wanted to introduce this semester, right? I want to click evaluate. If you go to Star UML, so let's show you where I got this from. So let's go to Star UML, right? And Star UML, you can download it from here, staruml.io. So I'm going to kind of copy this and put it onto my Slack channel here. I think this is a really cool tool, guys. And I know people ignore it because they're like, hey, I'm a coder. I don't need to know no stinking UML. I don't need to use any kind of patterns or plan anything. Let's just code, right? And then you get into problems like I'm having right now, where I have problems in thinking, okay? Please think about what you're doing, right? What you can do with Star UML, and this is really great to add into your game development document or somewhere else where you want to document your classes, especially when you make your own game engine, is start thinking about a class. So the first class that I might make, and this is how it works, this thing. So I have a class, and there's 3 sections to the UML diagram. Now, you guys should have learned this in object-oriented methodologies, and I think Professor Muhammad teaches this, right? So if you haven't had a chance to see Professor Muhammad, he does teach that course. I don't know what the course code is, but it's actually a pretty good course. And there's 3 sections. The first section is the name of the class, right? So in this case, let's suppose we call this game object, right? So on the right, you can see that there's some properties. So we can call this game object. And there's also attributes which are put in the second area, and methods, or operations, which are put in the third area, right? So there's 3 separate areas. So what you can do is I can go right-click, and I can add in some attributes. And we have some attributes. We can say that the first attribute is this width attribute, which, again, is of type number, okay? And the visibility is private, okay? Notice what it does. It says minus for private, underscore is my convention for private variables, right? Or and then the type, number, okay? Again, please, I know people hate UML, and they don't like planning, and you're developers, and you just want to get going, right? But it's good to plan some of this stuff. So I know I need this width, and I also know I need some other operators, so other attributes. Let's add another attribute called height. I won't do it all, but I want you to get the gist of what I'm trying to do, all right? So the number, it's a type number, right? There it is. And, oops, sorry, it's not public, it's private. Okay, so that's pretty cool. And those are a couple of attributes. Let's make the getter and the setter. And the way to do that is to specify an operation. So I say that I want to add a new operation. There's different options. There's just options here that you can add in, right? But here's an operation. And the operation is a method, right? And I'm going to say that it's width. That's the operation. But it also, you can specify that it kind of sets, it's both a setter and a getter, all right? I can kind of specify just from a typing perspective, if you will, right? It's public. Okay, cool. So you can say something like this, width. And again, I want to put in height. Here's an operation. I'm not going to do all of it because no time, but here's a height. So this is something that seems to be common, right, in my code, right? So width and height and half width and half height. And then if I have my game object, let's suppose I was planning, and I have a game object like label. So let's make a new class, right? And let's call this class label. Right, here's my label class. What I could do, right, is I can make an association, right? There's different kinds of associations that I can make, right? And there's different connections. Actually, you know what might be the easier way to do it? Let me just delete this first for a second. What you could do is you can actually click here, and if you double click, you can see that you can make a subclass which points to this class, and the subclass would be label. Right, there's my label class. And my label class would have width and height and these things, because that comes from my game object, right? But it would also have something different than what it has right now. It would not inherit from CreateJS text, right? It would have a CreateJS text component, right? So what I would have is a text component. So how would this look? It would be a public attribute, let's say. You can make it public, and which would be called text. So my text component, which would be of type, and I can do this, CreateJS.text, okay? I could do this, right? And this is something different. This is using the text value as a composed property, as opposed to inheriting from it, right? So you can imagine then that I can have another class over here, right, called CreateJS text. That's what that is, right? And my CreateJS text object is the thing that this thing is inheriting from, okay? In fact, it's a dependency. CreateJS text is a dependency to this. And I can draw a dependency line that goes from here to here. Okay? Because it depends on CreateJS text. If something changes in my CreateJS.text, then something would follow with my label. Because my text object inside of my label class would be an object of type CreateJS.text, not the whole label class being CreateJS.text object. And that's a different way of setting things up than what I've done so far. Does anyone have a question around this? I could do it this way. I'm not going to choose to, though. And I'll tell you why. If I choose to do it this way, right, we'll have some less duplication and some other problems, because what that might do is this is going to be a composed element, right? It's not going to be an inherited element like this. I'm not saying there's anything problem with composition. In fact, I prefer composition over inheritance most of the times, all right? But this might be more complex for some people. Going back, please, Star UML, I think I highly recommend it as a learning tool. So I have some similar things here. And you know what? For now, what I'm going to do, we may decide to do this otherwise. We might rewrite some of this stuff. So I'm going to grab all this stuff here, right? Copy it, right? And I'm going to go into my button class and inside here and paste it, because it can apply to this too, right? And this is where we have duplication. All right, we have duplication because, this basically says that, I can set my width and height, and those two things are the same, right? You can also make another kind of class, right? You can say that, there's one thing that CreateJS and Typescript do not allow is multiple inheritance, just like any normal or modern object-oriented programming language. It doesn't allow multiple inheritance. However, it does does allow the use of interfaces, which are very similar, as well as mix-ins, which is also something we can do. And mix-ins is like, I want to use a method of a class, but not the whole class. So it's kind of a weird thing. It's a different way of thinking. Some people don't like that, especially object-oriented programmers. Like, what? Mix-ins? But it does exist. Mix-ins do exist. In C++, object-oriented programming language, that most people use for game development, multiple inheritance is okay, right? You can use it. You just have to be very careful not to have that deadly diamond situation, right? But here in most object-oriented programming languages, modern ones, they say no. And it's because of type safety and problems when it comes to programming. So for now, we're going to not use it, and we're going to just do this kind of thing. In our constructor, notice I have some public properties already, so I'm going to get rid of this. In our constructor for the bitmap, though, it's slightly different. Our constructor looks like this. So constructor, I need in my constructor to call the super constructor. And notice what it needs. It needs an image or URL string. So I'm going to pass that in as the image string. I don't have that yet, but I'm going to get it from here. In my constructor, I'm going to get an image string, which is going to be of type string, right? I'm also going to get x coordinates, which is going to be a number, which I'm going to set to 0 by default. A y coordinate, which is going to be a number, which I'm going to set to 0 by default, right? And is centered, because I can also I might decide to center or not center the button, depending on my layout, which is also going to be of type Boolean, which is also going to be false by default. Okay, so that is going to be my constructor. Very similar to what I did last time, but slightly different. Also in here, I'm going to do the same thing. I'm going to say if is centered, right? I'm going to do something there. And I'm going to set the width and the height the same way. So it's quite a bit of duplication, but not so much that I'm totally concerned. It's only one time. So I'm going to grab all this code here, and maybe this one too. And the constructors look very similar too, right? That's the thing that bugs me when I do this. It bugs me because I'm like, it's almost the same. It's almost the same, but not. This is not the same, right? Here's one thing that can't be the same, because you can't use get measured width and get measured height with bitmaps. You can only use get bounds. So it's got to look like this: get bounds dot width and get bounds. And get bounds is getting the rectangle that kind of goes around the bitmap. It gets the rectangle around any bitmap and measures how big it is. That's what it does. All right. All right, so that is the button so far. Okay, so far so good, but buttons have different things that labels don't have. And this is where if I was going to inherit from the same class that label inherits from, thing would change, right? I want to create some event handlers for buttons. All buttons should have a mouse over and a mouse out event. So let's make those. So I'm going to say that this dot on mouse over I want to access this dot the over event, which I don't have yet, and this dot on mouse out. I want to access this dot out event. We're going to talk about this in a second. Over and out. Over and out, guy. Over and out. So here's the over and out. I'm going to make them public functions. Actually, sorry. Why should I? It should be underscore over and underscore out. Why is that? Because they're never going to be used by anybody else. That's why. It's going to be private methods, actually. So I'm going to say something like this dot, sorry, private underscore over is of type. I'm going to pass in an event object, which is going to be of type CreateJS mouse event, right? And returns void. I'm going to do the same thing with the out. Right, so over and out. There's over and out. And just like I did in the main game.ts file, if you look at the main game.ts file, I have over and out right here. Look, here's mouse over and here's mouse out. I want to get the alpha value of these things and change them, right? So I want to say something, and this is just my quick hit for a mouse button. You could also use a sprite replacement option where you replace the image that comes with the bitmap with some other image if you really want to here, okay? So I'm going to say that this dot alpha on over is 0.7, let's say, 70% alpha, 70% opacity, right? And on out, when the mouse goes out, this dot alpha is equal to 1.0, which is 100% opacity. So what that does is it makes it fully opaque when you're out, and some portion transparent when you're off, 30% transparent when you're over it. And these events are part of the constructor. They get called from the constructor function. So I can say this, these are event listeners. And these private methods are actually event handlers. And they're built into the mouse function, sorry, to the button function. However, can I make a mouse click event or a click event for the button? So all buttons have the same click event. Can I do that? The answer is complex. The answer is yes, I can. However, the behavior might be different for every button, which means I could make a subclass of buttons. So I can say, here's my button superclass, and then I want to make a special kind of button. I want to make a menu button, and my menu button has some other kinds of things. I think it's too complex, and I'd rather make my own click event outside of the class. All right, that's just me. However, you can also use a setter. You can say set click event to blah, blah, blah. Make it, set the code of the click event to something else, right? You can make it point to actually another function if you want to, but I don't recommend it. Now, there's no public methods in the button right now, right? But I could have one like set enabled, set disabled, or whatever. There's all kinds of stuff I can do in the public method section. I'm not going to do it because I just want to make this button work. All right, cool. So this is the button that I'm putting together. And what I'm going to do is I'm going to attach it to my index.html file. So I'm going to go back to my index.html. And just like I did with the object label, I'm going to make a new script call to connect my button. So /scripts/objects/button.js. Okay, so that connects my button to my project. So now my game engine includes a button. Okay. Thank you. Eventually, I would have picked that up, and here too for some reason. And what I could do is now in my game.js file, right? I'm just going to close these off because I don't need them. Instead of doing all of this work, it's all done for me a lot for the most part, right? On the top, I'm going to say that my click me button is not anymore of a CreateJS bitmap. It's actually of type objects.button. Right? And just like I did before in my button class, what I probably want to do in the constructor here to give me some help is use document this. So I'm going to put /**, and then pull down document this, which is going to really create a shortcut of all the methods that are required, or all the, properties that I need. All right, this is kind of documentation, okay, for the constructor. All right, going back to the game object. I know I have an error now because my click me button is not a bitmap anymore. It's of type objects.button. So I can replace this objects.button, right? However, does it meet requirements? It does, because remember, everything else is optional. However, let's add them in. I want to say that my X coordinate is 320, my Y coordinate is 360, and it is centered, is true. This button is centered. And guess what I can get rid of? I can get rid of all this in my code. Plus, I can also get rid of these two event handlers. So now, the only thing I had in here is my click me button click event, because that would be different for every button. However, again, maybe in an advanced session or later on, we may change this to create a function that we point to, that we set the function. We can override the function that exists with my click me button to something else. Okay, if everything worked, if I save my code, and if I go back out to my site, we should have this same effect, right? If I refresh just to make sure, you can see that in my scripts, I have two objects. I have a button and a label, right? And right now what I'm doing is in my index.html, I have both label and button. And this, my friends, is of type button, objects.button, right? As opposed to CreateJS.bitmap. So now we have two things, a label and a button. And this same methodology that I used today to make a label in a button class is what I'm going to be using going forward to make my player, my enemies, everything, all my objects that I'm going to be making here. I'm going to be using this methodology where I have different files for each of my JavaScript classes. Okay? That's all I want to share with you today. All right? Any questions? Let me put this up on GitHub. So I'm going to go here. I'm going to add all this up. So I'm using the built-in Git control in Visual Studio Code. I'm going to click this little plus sign, which means stage all changes. That's like saying git add dot. That's what that does. And then I'm going to add a comment. I'm going to say added button class. And then I'm going to click this check mark. And that's like doing git commit -m added button class. That's what I just did, those two things, right? And then I'm going to push it like this, which is like doing git push origin master. That's equivalent to what I just did. And if I look up online, and if I refresh, you can see that in my code, I have 6 commits, right? Some that I did last week, and 2 that I did this week. This is this week's commits, right? I added a label class, and I added a button class. Any questions at all about how we're building our game engine? So far, not a lot of stuff. Parting thoughts. If you think about game engines and how the classes can be set up, this is one way of setting up a game object. But what I'm probably going to go do next week is I want to set up a game object that is some kind of display object for CreateJS, right? And also, we're going to use some other objects that we're going to create for the scene. Next week, we're going to talk about finite state machine, which is a pattern that we're going to be using to switch between one scene and another scene, right? And we're going to be using something called the container class, right? The container class is built into CreateJS. And it would look something like this. Just going to make a new diagram. App was unexpectedly terminated. I love that. See if I can get rid of this stuff. I'm going to make a new diagram for next week. It's going to look something like this. I have a container class, and it's called container. So CreateJS, actually, it's of type CreateJS. Thank you. .container. Please remember to submit tonight your contract. Okay. CreateJS container, actually, if you look at what I'm doing, this CreateJS container class, it actually comes from the API, the CreateJS API online. So if I go up online and I look at easel.js and I look at the container class, here it is. It actually inherits or extends the display object superclass, right? And what this allows me to do is create containers, and the container will wrap any objects that I put inside of it. So I want to use the container to create something called a scene class. And my scene class is where all my objects are going to be added. The container class also has an add child method. So I can add children to the container class, the scene class. And then I add my whole container to the stage, which is a totally different way of doing things. Because if I was to, add everything to the stage directly, that means I'd have to wipe out every single item on the stage before I go to the next scene. But if I add it to this scene class, this container class, right, then I can just wipe out the whole container and make a new one, right? Which is way faster and better than if I was to use individual objects. So this container class, what I'm going to do is I'm going to make it so for next week, I'm going to, sorry, it's actually better to do this. I'm going to add a subclass of it, and it's going to be called the scene class. So this is what I'm going to be doing. So here's my scene class. So the scene class is actually going to be inherited from CreateJS's container class. That's what it's going to be. And the scene class has add child and a bunch of other things. But the scene class also has some other properties, right? In fact, I'm going to have several methods that you're going to be familiar with if you've ever done Unity, which is, if I were looking at the operations, if I had an operation, I'm going to have the start operation, okay, which is public. I'm also going to have something called update, right? So another operation called update, right? I'm also going to have an operation, right? Here's an operation or a method, if you will. That's what operations are. A method called destroy, right? So I can call the start method, the update method, or the destroy method, right, of my scene. I'm also going to have a scene method called main. There's going to be a main. Well, actually, should I? What did I do last time? I think, no, I had a reset. I had a reset method. And the reset method would reset the scene back to normal, okay? And this scene class, this is interesting. I would make this an abstract class, okay? So it wouldn't be a class that you can inherit from. And then from this is coming next week, by the way, guys. From this, I would create several subclasses, all right? And the way it would work would be, I would make a start scene. So let's make the start. I'm just going to name them, okay? Start. The start scene. I would make another subclass. Maybe we'll call this the play scene, right? Play. And maybe one more for now, because I would make. Remember, I told you you need at least these elements for your game. And by the way, you need everyone here needs these three scenes for sure, minimum in your game: start, play, and end. And think about the play scene. I want you guys to think about the play scene as the first level, level 1, right? So these three scenes are going to inherit from the scene class, which is going to inherit from the CreateJS container class, right? And what I can do here is I can say, hey, if start, play, or end are scenes, right, I can use a scene switcher to switch between these scenes. So it's using this finite state machine pattern, which I'm going to talk about next week, okay? Questions around anything that we did this week? All right, cool. Next week, please remember that tonight your contract is due for your team. If you haven't had a chance to finish it, please finish it and put it up on eCentennial. Please also mention when you submit it who your team members are, right? So I can give everyone credit, right? Also, remember that next week you're going to have to do your game pitch, which is due beginning of class. So when you come in, you're going to do your presentation, your game pitch presentation to the class. talking about your game idea. That you're going to do it in the beginning of class, but the actual PowerPoint document or slide deck and your game design document is due by the end of class, at the end of day next week. Okay, that's due next week. Okay, so that's your game pitch. Next week, I'm going to give you assignment 1 that's coming, right? Assignment 1 is coming next week. And it's going to be an individual assignment based on some of the stuff we've been talking about this week and the stuff I'm going to give you next week, because I'm giving you finite state machine pattern next week, right? You'll have a couple of weeks to do your assignment 1 on your own, right? To get familiar with the CreateJS library, right? There's an individual assignment that's going to be worth 12% of your final grade, okay? So it's coming. All right, so that's what's happening over the next couple of weeks, right? This week or next week. And then the week after that, there's going to be the first release. I think you have a week or 2 to do your first playable, right? Also next week, I may have an in-class assignment, an in-class exercise, a lab, where I get you to submit your finite state machine pattern. It was going to be a little bit of an exercise on how to do that. All right, guys, thank you so much, and we'll see you next week.
So, say you need to submit 2 things.